Continuing with try yourself problems, laws of motion. Question number 18. An object of mass 10 kg moves at a constant speed of 10 meter per second. A constant force that acts on the body for 4 seconds gives it a speed of 2 meter per second in opposite direction. The force acting on the object is, they have given mass is 10 kg, initial velocity is 10 meter per second, and the time for which the force acts is 4 seconds, and the final velocity is 2 meter per second and in the opposite direction, so it is minus 2 meter per second. So we have V is equals to V naught plus AT, or A is equals to V minus V naught divided by T, that is minus 2 minus 10 divided by 4, which is equals to minus 12 by 4. So which is minus 3 meter per second square. Therefore force is F is equals to M into A, mass is 10 kg, acceleration is minus 3, which is nothing but minus 30 Newton. That is option B is the right answer. Question number 19. A body of mass M collides against a wall with a velocity V and rebounds with the same speed. Its change in momentum is. So let us consider the initial velocity is V. It rebounds with the same velocity. So final velocity, let us consider this is Vi. This is Vf. Vf is nothing but minus V. So we have the change in the momentum delta P, which is M into final velocity minus initial velocity. So it is M into minus V, which is nothing but minus 2M into V. So option A is the right answer. Question number 20. The recoil velocity of 4 kg rifle that shoots a 0.050 kg bullet at a speed of 280 meter per second is. Now we have mass is given as 4 kg. Okay, that is the rifle velocity. Let us consider it as a mass of the gun. Shoots a bullet of mass 0.05 kg. So the bullet at a speed, initial speed of the bullet is nothing but it is given, that is Vb is equals to 280 meter per second. So applying the law of conservation of momentum, total linear momentum before firing is equals to total linear momentum after firing. So total linear momentum before firing, that is considered as 0. So 0 is equals to mv Vb, mass of the bullet, into velocity of the bullet, plus mg into Vg. Therefore Vg is equals to minus mv Vb divided by mg. Substituting the values, we have minus 5 into 10 to the power minus 2, that is mb, into 280 divided by mass of the gun, which is 4. 4 ones are 4 70s are, so which is minus 350 into 10 raised to minus 2, which is minus 3.5 meter per second. So velocity of the recoil velocity of the gun is minus 3.5 meter per second. So option B is the right answer. Question number 21. A 10 kg object collides with stationary 5 kg object, and after the collision they stick together and move forward with a velocity of 4 meter per second. What is the velocity with which the 10 kg object hit the second one? So here let us consider m1 is equals to 10 kg, then the stationary object. Okay, so here u1 we have to find the value of u1, m2 and m2 is given as 5 kg, and the initial velocity of m2 is 0. So final velocity, the objects stick together and they move with the common velocity, it's 4 meter per second. So again applying the conservation of linear momentum, we have m1 u1 plus m2 u2 is equals to m1 plus m2 into v. So m1 is 10 into u1 plus 0 is equals to 10 plus 5 into 4. So u1 is equals to 10 plus 5 is 15, 15 into 4 is 60, 60 by 10, which is nothing but 6 meter per second. So option B is the right answer. Question number 22. An ice cart of mass 60 kg rests on a horizontal snow patch with coefficient of static friction 1 by 3. Assuming that there is no vertical acceleration, find the magnitude of the maximum horizontal force required to move the ice cart. So we have the mass of the ice cart, which is given as 60 kg, and the coefficient of friction mu s is 1 by 3. Find the magnitude of the horizontal force required to. So force is nothing but F is nothing but mu s into N. That is mu s is into M into G. So that is mu s is 1 by 3 into 60 into 9.8, that is 20 into 9.8, that is 196 Newton. So option D is the right answer. Question number 23. A cork of mass 10 kg is floating on water. The net force acting on the cork is, here the cork is floating on the water, so it is in an equilibrium position. So here if you consider this is a cork, here the weight is acting vertically downwards, that is mg, and the reaction force is acting vertically upwards. Here it is in an equilibrium position, that is nothing but here N is equals to mg, or F net is nothing but N minus mg. Since N is equals to mg, the net force acting on it is 0. So option D is the right answer. Question number 24. A trolley of mass 20 kg is attached to a block of mass 4 kg by a massless string passing over a frictionless pulley, as in the figure. If the coefficient of kinetic friction between the trolley and the surface is 0.02, then the acceleration of the trolley and the block system is given. G is 10 meter per second square. So let us consider here the force acting. The first, let us consider the figure. So we have a 20 kg of trolley and it is a pulley, and we have a 4 kg object. Now here let us consider this is a mass m1, this is a mass m2. Here the weight acting is vertically downwards, that is m1 into g. Under tension acts towards the support, that is t. The acceleration is downwards. If you consider the mass m2, here the tension again acts towards the support, the tension is t, and acceleration acts towards the right direction. So writing the equation for m1 and m2, we have the first equation, the net force for mass m1 is m1 into a is equals to m1g minus t. If you consider the m2, then we have the second equation. So here they have given the kinetic friction acts between the trolley and the surface. If the object is moving towards the right, the kinetic friction acts towards the left, that is, let us consider it as Fk. So equation becomes m2 into a is equals to t minus Fk. So here I add the two equations. Let us consider equation 1 and equation 2. Equation 1 plus equation 2. So we get m1 plus m2 into a is equals to, t get cancels, so it is m1g minus Fk. Here Fk is nothing but mu k into n, that is mu k m2 into g. N is m2g. So substituting here, we have m1 plus m2 into a is equals to m1g minus mu k m2 into g. So equation for acceleration is m1g minus mu k m2g divided by m1 plus m2. So substituting the values, we can take g as a common. So it is 4 minus 0.02 into 20. G is considered as 10 meter per second square divided by m1 plus m2, that is 4 plus 20, which is 24. So we have 3.6 into 10 divided by 24, which is nothing but 36 by 24, which is 3 by 2, that is 1.5 meter per second square. So option C is the right answer. Question number 25. The coefficient of friction between the tires and the road is 0.1. Mu s is 0.1. The maximum speed with which a cyclist can take a circular turn of radius r is 3 meter without a skidding. So we have the equation for a maximum velocity when the vehicle turn in a circular path is given by Vmax is nothing but square root of mu s into rg. So substituting the values, we have mu s is 0.1, r is 3 into 10, that is root 3 meter per second. So answer B is the right answer. Question number 26. A circular racetrack of radius 300 meter is banked at an angle 15 degree. The coefficient of friction between the race car and the road is 0.2. The optimum speed of the race car to avoid the wear and tear of its tires is. So they have given the angle theta, that is banking angle, that is 15 degree, and the radius is nothing but 300 meter. So there is a coefficient of friction between the wheels and the car. They have given it as 0.2. We have to find the optimum speed of the race car to avoid the wear and tear of the tire. The wear and tear of the tire is caused because of the friction. So we have to consider here, for the optimum speed, the frictional force is 0, that is mu s is equals to 0. So V is equals to, we have the equation square root of Rg tan theta plus mu s divided by 1 minus mu s tan theta. When mu s is equals to 0, if we substitute, we get the equation for the optimum speed, that is V is equals to Rg tan theta. So substituting the values, we have R is 300, G is 10 and tan 15. So we have 3 into 10 raised to 3 into 0.27. Tan 15 value is given as 0.27. So it can be written as 3 into 10 raised to 3 into 27 into 10 raised to minus 2. So 27 into 3 is 81. 81 into 10, that is root of 81 is 9. 9 root 10 meter per second. So optimum speed is 9 root 10 meter per second. So option B is the right answer. Question number 27. The maximum permissible speed to avoid slipping in the above question. So when we have to avoid slipping, then we have to consider the frictional force. They have given the coefficient of friction is 0.2. So the maximum permissible speed without slipping, when we consider the frictional force, is nothing but V is equals to square root of Rg tan theta plus mu s divided by 1 minus mu s tan theta. So substituting the values, we have the radius is given 300, into 10, 0.27 plus 0.2 divided by 1 minus 0.2 into 0.27. So simplifying, we get 3 into 10 raised to 3 into 47 into 10 raised to minus 2 divided by 1 minus 0.054. So which is square root of 141 into 10 divided by 0.946. 0.946 is approximately equal to 1. So we can consider this as square root of 1410. So when we take the square root of 1410, we have approximately, we get the answer as 38.6 meter per second. So option C is the right answer. Question number 28. An aircraft executes a horizontal loop at a speed of 720 km per hour with its wings banked at 15 degree. What is the radius of the loop? So we have the velocity, that is 720 km per hour, converted to meter per second, that is 720 into 5 by 18, which is nothing but 40, 18 ones are 18, 40s are, that is 40 into 5, which is 200 meter per second. So theta banking angle is given 15 degree. So we have the maximum speed, V max, is given by square root of Rg tan theta. So substituting the values, we have 200 is equals to square root of, we have to find the value of R into 10 into tan 15. Square the given equation. So we have 200 square is equals to R into 10 into tan 15 is given, that is 0.27. So R value is 4 into 10 raised to 4, that is 200 square, divided by 10 into 0.27, that is 2.7. That is nothing but 1.48 into 10 raised to 4, or it is 14.8 into 10 raised to 3 meter, which is which is 14.8 kilometer. So option A is the right answer. Question number 29. A batsman deflects a ball by an angle of 45 degree without changing its initial speed, which is equal to 54 km per hour. What is the impulse imparted to the ball? Given mass of the ball is 0.15 kg. So they are given, suppose if you consider this is a ball, the total deflection is given as 45 degree. So when we consider here, this angle is nothing but it is 22.5 degree. So when we consider here, they have given the speed is nothing but let us consider u 54 km per hour, converted to meter per second, that is 54 into 5 by 18, that is nothing but 18 ones are 3, 18 threes are 54, that is 15 meter per second. So when we consider the initial momentum, so the initial momentum is nothing but it is mu cos theta, that is nothing but 0.15 into 15 into cos 22.5 degree. here we have the component only along the mu cos theta, mu sin theta component get cancels with each other. So here it is 0.15 into 15 into cos 22.5 degree is 0.9239. So let us consider this is N, this is O. That is nothing but along NO direction. Now if you consider the final momentum, again if you consider the velocity here, with the same velocity it is deflected. Again it has velocity has a two component along the horizontal and along the vertical. As I said, the vertical component cancels with each other. So final momentum is nothing but it is mu cos theta, that is impulse is nothing but change in the momentum, so it is mu cos theta minus mu cos theta. The component of NO along this will be along this direction. Let us consider it as AO. If you consider the component of final velocity U, the horizontal component acts along the opposite direction. So we are considering the along to the left, let us consider it as positive, along to the right we can consider it as negative. So we have mu cos theta minus mu cos theta, so which is plus 2 mu cos theta, that is 2 into 0.15 into 15 into approximate it is 0.92. So we have 4.16 kg meter per second. So option A is the right answer, approximating it to 4 kg meter per second. Question number 30. If a force of 250 Newton act on a body, the momentum acquired is 125 kg meter per second. What is the period for which the force acts on the body? So we have the force acting on the body, which is 250 Newton, and the change in the momentum, which is nothing but 125 kg meter per second. So we have the impulse is nothing but F into delta t, which is nothing but the change in the momentum delta p. So delta t value we have to calculate, that is delta p by F. Delta p is 125 divided by 250. So which is 1 by 2, which is 0.5 second. So option A is the right answer. Question number 31. A cricket ball of mass 150 gram has initial velocity u 3 I cap plus 4 j cap meter per second, and the final velocity v is minus 3 I cap plus 4 j cap meter per second. The change in the momentum is, after being hit we have to find what is the change in the momentum. So mass is given 150 gram, that is 150 into 10 raised to minus 3 kg. So initial velocity is given as 3 I cap plus 4 j cap meter per second, and the final velocity is minus 3 I cap plus 4 j cap meter per second. We have to find what is the change in the momentum, that is delta p is m into v minus u, final velocity minus initial velocity, that is 150 into 10 raised to minus 3 minus 3 I cap, multiplying negative sign inside, minus 4 j cap minus 3 I cap minus 4 j cap. So we have 150 into 10 raised to minus 3 minus 6 I cap minus 8 j cap. So it is we can write this as minus of 90 I cap plus 120 j cap into 10 raised to minus 2. So we can write 150 as 15 into 10, 10 into minus 3 is minus 10 to the power minus 2. So when you multiply 10 to the power minus 2, we have minus 0.9 I cap plus 1.2 j cap. So option C is the right answer. Question number 32. A cricket ball of mass 150 gram collides straight with a bat with a velocity of 10 meter per second. Batsman hits it straight back with a velocity of 20 meter per second. If the ball remains in contact for 0.1 second, then average force exerted by the bat on the ball is. So mass is given 150 gram, 150 into 10 raised to minus 3 kg. Initial velocity V naught is 10 meter per second. Its final velocity is minus 20 meter per second in the opposite direction, and the time of impact is nothing but it is 0.1 second. So we have the impulse F into delta t is delta p, that is F is equals to m into V minus V naught divided by delta t. Substituting the values, we have F is equals to 150 into 10 raised to minus 3, that is minus 20 minus 10 divided by 0.1, so which is nothing but 45 Newton. So option B is the right answer. Question number 33. A block of mass 1 kg is at rest on a horizontal table. The coefficient of static friction between the block and the table is 0.5. If G is 10 meter per second square, then the magnitude of the force acting upwards at an angle of 60 degree from the horizontal that will just start the block moving is. So we have a block which is resting on a horizontal table. They have given a force at an angle of 60 degree with respect to the horizontal. So we have to find what is the magnitude of the force F. The minimum force we have to apply so that the block just starts its motion. So when we consider here, the forces acting are weight of the block, that is mg vertically downwards, normal reaction n upwards. So if you consider F has two components, that is along the horizontal we have F cos theta, and along the vertical we have F sin theta. We know that the object is not moving in a vertical direction, so n plus F sin theta should be equal to m into g, or n is equals to mg minus F sin theta. And here if you consider the object is moving along the horizontal, the frictional force is nothing but it acts in opposite direction. We can consider it as Fs. So we have the second equation, F cos theta is equals to Fs. Fs is nothing but it is mu s into n. So it is mu s into n. Here we have n equation. Substitute F cos theta is equals to mu s into n is mg minus F sin theta. So substituting the value, we have F cos 16 is equals to 0.5 into 1 into 10 minus F sin 60. So F cos 60 is 1 by 2 is 0.5 into 10 minus F into root 3 by 2. So take F value to the other side, multiply 2 inside the bracket, to the right. So it is F is equals to 1 into 10 minus F root 3 by 2, or it is F plus F root 3 by 2 is equals to 10. So F is, taking the LCM, 2 plus root 3 by 2 is equals to 10. So F is 20 by 2 plus root 3. Root 3 value is 1.73, that is 20 divided by 3.73, which is 5.36 Newton. So option B is the right answer. Question number 34. A maximum speed that can be achieved without skidding a car on a circular unbanked road for a radius r and the coefficient of friction mu s. If you consider the circular turn here, this is a road. So without a banking, let us consider this is a car. Okay, here for a car to take a circular turn, the force acting is nothing but it is a centripetal force. The necessary centripetal force for a vehicle to take a circular turn is given by the static friction between the road and the tire, that is Fs. So we have Fs is mv square by r, Fs is mu s into n, n is nothing but m into g. So mv square by r is equals to mu s mg. So v square is equals to mu s r into g, or v is equals to square root of mu s into rg. So right option is option D, mu into rg. Here radius is given as capital mu r into g. Question number 35. The minimum velocity with which a driver must traverse a flat curve of radius 150 meter and the coefficient of friction 0.6 to avoid skidding is. So without a banking, we have V is equals to square root of mu s into rg. So the substituting the value, we have 0.6, r is 150 meter into 10. So that is 6 into 150, that is 15 into 6 is 90 into 900, that is 150 into 6 is 900, square root of 900, which is nothing but 30 meter per second. So option B is the right answer. Question number 36. Refer to the system shown in the figure. The ratio of tension T1 and T2 is. So here this is a tension T1, here this is a tension T1, and here the force acting is given as T2. So if you consider the figure here, the force is acting towards the right, therefore the net force acts along this direction. The body moves along to the right. So T2, the force can be written as m1 plus m2 into A. So if you consider the block m1, the force is T1 and acceleration is A. So T1 is equals to m1 into A. So taking the ratio, we have T1 by T2 is equals to m1 into A divided by m1 plus m2 into A. A get cancels, so T1 by T2 is equals to m1 by m1 plus m2. So option A is the right answer. Question number 37. Three blocks of masses m1, m2 and m3 are connected by a massless strings as shown in the figure in a frictionless table. They are pulled with the force T3 is equals to 40 Newton. M1 is 10 kg, M2 is 6 and M3 is 4 kg. What is the tension? T2. So here if you consider the force is F is given as T3, which is nothing but 40 Newton. So since the force is acting towards the right, the three objects moves with the acceleration a along the right direction. So here 40 F is equals to m into a, so 40 is equals to m1 plus m2 plus m3 into a. So we can calculate a, that is 40 by m1 plus m2 plus m3, that is 10 plus 6 plus 4, which is 40 by 20, which is 2 meter per second square. Acceleration is 2 meter per second square. So we have to find what is the value of the tension T2. So if you consider M3 here, one, that is the 40 Newton force acts towards the right, and the tension T2 to the left, and the net force acts towards the right. So that is M3 into A, net force is nothing but 40 minus T2. So T2 is equals to 40 minus M3, M3 value is 4, into acceleration is 2, that is 40 minus 8, which is nothing but 32 Newton. So T2 value is 32 Newton. So option D is the right answer. Question number 38. Refer to the system shown in the figure. The acceleration of the masses is. So we have the system consists of 3 objects moving over a frictionless pulley connected by the strings. We have B, C and A. Here A is 5 kg, B is 3 kg and C is 1 kg. So if you consider the object A, here we have the weight acting, that is MA into G, and the tension T. Here 5 kg is greater compared to the masses of B and C. Therefore, the acceleration will be in a downward direction. Here for the B and C, if you consider the tension here, T acts in the vertically upward direction. So the net acceleration acts in the upward direction. So writing the equation for the object A, we have MA into G minus T is equals to MA into A. For the second object B and C, that is the B has to carry the weight of C here, so the tension is T. So we have T minus the net weight acts vertically downwards, that is MB plus MC into G is equals to M into A, that is M into A is nothing but MA plus MC, or we can write this as MB plus MC into A. Let us consider this as equation number 1 and this is equation number 2. Adding equation 1 and equation 2, we have MA into G minus MB plus MC into G is equals to, A is common, so MA plus MB plus MC into A. So here T plus T and minus T get cancelled. Substituting the values, we have MA is 5 into G minus MB plus MC is 4G, which is equals to 5 plus 3 plus 1 into A, that is 5G minus 4G, which is equals to G, which is 5 plus 3 plus 1 is 9 into A, or A is equals to G by 9. G by 9 meter per second square. So option C is the right answer. A body of mass 2 kg travels according to the law x of t is equals to pt plus qt square plus RT cube, where P is equals to 3 meter per second, Q is equals to 4 meter per second square, and R is 5 meter per second cube. The force acting on the body at T is equals to 2 seconds is. So we have a position equation, that is x is equals to pt plus q t square plus r t cube. We can find velocity v as dx by dt, that is d by dt of x equation. Therefore, when you differentiate this above equation, we have t plus 2q into t plus 3r t square. Sorry, this is p. Differentiation of t is 1, so this is p. So again we get acceleration a as dv by dt. So differentiation of p, which is a constant, is 0. Differentiation of 2qt is 2q plus differentiation of 3rt square is 6rt. So we have to find what is the force at t is equals to 2 seconds. So acceleration at t is equals to 2 seconds is, q value they have given it as 4 meter per second square, and r value is 5. So substituting, we have a is equals to 2 into 4 plus 6, r is 5, t is 2. So it is 8 plus 60, which is 68 meter per second square. Therefore, we have from second law, F is equals to m into E. M is 2 into 68, that is 136 Newton. So option A is the right answer. Question number 40. A body of mass 5 kg is supported by a light cord. Find the tension in the cord. So we have a object of mass 5 kg which is supported by a cord. We have to find what is the tension. The tension acts towards the support and the weight acts vertically downwards, m into g. Here the object is in equilibrium, so net acceleration is 0. So we can write t is equals to m into g, or t minus, because t minus mg is equals to 0. So t is equals to mg, which is nothing but 5 into 10, which is equals to 15 Newton. So option C is the right answer.